All right, so today we're going to review some factoring skills that you all have already learned and also get to one new piece of factoring. Later in chapter 4, after break, we're going to need some factoring, and so let's review. So, first steps for factoring, look for a GCF, right? If there's a GCF, it has to be taken out to make your life easier and also just to factor completely. You might be done after that. Who knows? Is there more to factor after you take a GCF out? And there might not be a GCF, but sometimes. All right, a special pattern, difference of perfect squares. You know this already. That's kind of like in number 4 down here, 9 and 64. You're like, oh, that's 3 times 3 and 8 times 8. So you recognize those. Some are difference of perfect cubes. You do not know this. This is something new that we're going to do today. All right, and then the next thing to think about, if you don't have any special things going on, if your leading coefficient is 1, that'll make your life pretty easy. Like if you have 1x squared plus whatever or minus whatever. And then if you have a leading coefficient besides 1, so if you have like a number like a 3x squared in front, that makes things a little bit harder, but also not too bad. So let's get started. So a GCF, maybe write that big on your paper. GCF. All right, make sure you check for that. So this is the type of work that you're going to have to show when you do your classwork for us. On number 1, I noticed that there's an x. Now, if you feel like dividing the x like this and showing that, that's fine, or you're very welcome to do it in your head. But either way, you pull an x out and you have x squared plus 10x left minus 24. Okay? Then I look at that and I'm like, I think I can probably factor that some more. So I got x and x. All right, so things that make 24, remember. So 12 and 2, 6 and 4, 8 and 3, 24 and 1. So right away on my list, this is kind of an easy one because it's a x squared in front, so there's no number. The leading coefficient is 1, so it's like I'm doing this type of style problem right here. So 6 and 4, I'm like, oh, that makes 10. But I put 6 and 4 here, and I do notice that if I did that, they have to both be positive to make 10, positive 10. And that's not going to get me a negative 24. So I do not want 6 and 4. I think I'll try 12 and 2. So 12 times 2, there we go, is 2x. This part's 12x. So I'm like, okay, 12 minus 2 makes 10. There we have it. Because if I put a plus 12 and a minus 2, we've got it. Now, let me be clear here. When you do your work in class, you will have to show that you're taking out the x. You will have to then show for your final answer that you have your final answer, obviously. And you also have to write these pieces right here. Show that you are thinking and doing that. We're not using Photomath. We are doing this ourselves, right? If you do not show these 3 things, then you won't get credit for your problem. All right, so for number 2. Let's see, 6x squared minus 11x plus 4. There's no GCF in that. They don't all divide by a common factor, and let's try it out. So when I'm looking at this, 6x squared is kind of suspicious. I can either make that a 3x times a 2x to make 6x squared, or I can make that a 6x and a 1x to make 6x squared. And so these are kind of a pain. But luckily the 4 on the end only got 2 and 2, and also 4 and 1. So let's think about 2 and 2. If I were going to do 2 and 2, I'd have to put a 2 here and a 2 there, or a 2 here and a 2 there, and that's not going to work for me. Because remember, I can't put anything with the 6x that goes into 6x. I can't put anything here that goes into 2x, so I can't use 2 and 2 in either scenario. So I'm going to erase all those, and I'm not going to use 2 and 2. So let's try 4 and 1. So if I was doing 4 and 1, the 4 would have to go here, and the 1 there. Or in this case, 4 here and 1 there. So you don't have to do these at the same time, but I'm just trying to show you all the options. On this bottom one, I'm getting 24 and 1, and this is the only way I can place the numbers, and 24 and 1 don't make 11. So you know what? This bottom option is never going to work. So that's how we whittle it down. All right, so up here I'm getting 3x, and I'm getting 8x, and that's perfect because I want negative 11. If I make them both negative, everything's going to work. 2 negatives make a positive 4. All right, so remember, you have to show all those steps. Or show basically what you've done right here is you factored it, so here's your final answer, and then you have to show these little loops here that you've drawn and thought about the center. All right, over here, 4x to the third, 10, 24, they have a GCF of 2 and x. Which one I divide out leaves me with 2x squared minus 5x minus 12. So remember, I am dividing each of these things by 2x, and if you want to write that, you may, if that helps you. All right, so I got 2x, and 2x squared is 2x and x. So for 12, I have 6 and 2, 12 and 1, 4 and 3. Now, 6 and 2 will never work because I cannot put a 6 or a 2 right here, so I'm not going to try that. All right, and let's try, I don't know, 4 and 3, how about? So I'd have to put the 3 here and the 4 there. That makes 8x and 3x, and we've got it. Negative 8 plus 3 makes this negative 5 right here. So I would have a negative and a plus. Remember, you have to show all those steps. Now, this is your answer, but you are not going to get credit unless you show the other steps. All right, number 4. So I have 9 and 64, and honestly, this is a little suspicious because there's only 2 parts. So hopefully you remember that might be perfect squares, and these are perfect squares. 9 is 3 times 3, 64 is 8 times 8. So let's try that. So I have 3x, and 64 is 8 and 8. The reason this works is because this is 24x, this is 24x. If I make one plus and one minus, they cancel out, which is great because I don't see any x's in the middle. So plus and minus, there we go. All right, number 5. A GCF I noticed right away, they have x squared, and also 2 divides in there. So I take a 2x squared out, which leaves me with 25x minus 8 divided by 2 is 4. And that's it. I took the GCF out, and what I have left right here, the 25x minus 4, is done. If it was 25x squared minus 4, it might be, like this problem over here, but it's not. So this is complete and finished. All right, number 6. On number 6, something to notice here a little bit is perfect square, but this time there is a middle term. So this is going to be a little special case that we'll get to, but let's just try it out. Like, I'm approaching this problem, I'm like, okay, well, let's see. 4x squared, that could be 2x and 2x. I don't know, it could also be 4x and 1x. I don't know. But 9 luckily is only 3 and 3 and 9 and 1. So let's try 3 and 3. So that one makes 12. That one makes 3x, 12x. That's not going to be 12. Let's try 3 and 3 up here. That makes 6x and 6x up. That makes 12x. If they're both negative, then I get 2 negatives here, and then I have positive 9. So it's all set. So I didn't need that other one after all. So notice that when you have perfect squares on the ends and a number in the middle, what's going to happen here is you get the same thing twice. So it's similar to number 4, but you have the same sign. So if you want it to be fancy, you could write 2x minus 3 to the second power. All right, so 7, 8, and 9, these are some new skills here. So these are going to be talking about perfect cubes. Now we're used to perfect squares because everybody knows, 25 is 5 squared, 36 is 6 squared. Everybody knows they're perfect squares by heart usually. But perfect cubes are not always the case. So let's try a few. So 1 to the third, it just means 1 times 1 times 1. That's 1. 2 to the third, 2 times 2 times 2. That's 8. 3 to the third, 3 times 2 times 3 is 27. Let's do 4 to the third. 4, 4, 4 is 64. And we'll stop at 5. We could go on forever. 5 times 5 times 5 is 125. And, you can keep going, obviously, but I've only used up to these 5 numbers. So I want you to recognize in these problems here that you have perfect cubes. 8, 125, 64, 27. And even up here, there's a 1 right there, right? So even right there, there's a 1x to the third. So these are all perfect cubes. So recognize also that you can have a plus or minus. It doesn't matter. Back in perfect square land, you could only use a minus when you were doing this, but now you can use either one. All right, let me erase this up a little bit. Don't want all those markings there. So when you approach a problem like this, I want you to do this. I want you to think to yourself, what did I cube to get this item that I have right here? So for instance, x cubed. Well, x cubed is literally x cubed, right? What did I cube to get 8? Well, 8 is 2 cubed, right? So that's 2 cubed. And if we write it like this, it's going to be a little easier for us in the long run. This one, what did I cube minus what did I cube? So what did I cube to get 8x cubed? 8 is 2 times 2 times 2, so it's a 2, and I have an x. 125 is 5 times 5 times 5. Over here, what did I cube to get 64, x to the third? And what did I cube to get 27? So this would be 4. It's on our list right here, and x, and 27 is 3. So if you kind of piece it up like that, what we're going to do is we're going to take these two pieces, okay? So when we go to factor it, it has a special pattern. So it has a pattern when we factor it to be this small piece and then a larger piece. And I say small piece because this first parentheses is going to have 2 items in it. Those 2 items that go right here are going to be the pieces that you picked earlier. So they are going to be these pieces right here, this x and this 2 that you picked from earlier, or that you figured out earlier. So you're going to put x and you're going to put 2 right here. Okay. Now, the next piece is going to go like this. It's going to have three items in it, 3 terms. It's going to go like this: square, the middle part, write the word multiply, and square. Square, multiply, square. All right, so this is what I'm going to do. I'm going to take this first item and I'm going to square it. Well, x squared is x squared. Then I'm going to take both items right here, and I'm going to multiply them together. Well, x times 2 would be 2x. And then I'm going to take this last item and square it. 2 squared is 4. That's how you get your 3 pieces on the other side. You do square, multiply, square. And then I want you to think of this word, soap. That's going to be our little mnemonic. It means same, opposite, always, positive. All right, so the first letters of the word, right? Same, opposite, always, positive, soap. All right, so how we figure out our signs is we do this. In the first parentheses, we use the same sign that there was to begin with, plus. Then I do the opposite of that here, and I do always positive. And we're done. And I will show you in class how you are going to, how this multiplies back out and why it works. But for now, just know that that's how you factor it. All right, so when you do this, you're going to show me your work. You're going to show me that you thought about this. And then, of course, you're going to show me your final answer. There's no little loops to draw in these problems. All right, next one. So remember, little parentheses with 2 parts, bigger parentheses, a trinomial with 3 parts. So in the first parentheses, you put these 2 items that you already found, 2x and 5. These were the items that got cubed to get your original problem. Remember here, I'm going to do square, multiply, square. So I take 2x and I square it. Well, 2x times 2x is 4x squared. Then I take 2x and multiply it by 5. That would be 10x for the middle. Then I take my 5 and I square it. 5 times 5 is 25. Then I come through with my signs. Same, so it's a minus because it was a minus here. Opposite, because opposite of minus is plus. Always positive. And you're finished. Remember that you have to show this breakdown right here, and then you have to have your final answer. Okay. All right, last one. So remember we thought of 4x because 4 times 4 times 4 is 64, and 3 times 3 times 3 is 27. So I have a binomial and a trinomial. So 4x goes here, 3 goes there. I do square, multiply, square. So I take this 4x and I square it. 4x times 4x is 16x squared. So you can think of it like this: 4x times 4x, that's squaring it, or you can think of it like this: 4x squared. Either way, it's 16x squared. Then I take 4x times 3. I multiply them together and I get 12x. And then for the last part, I have 3 squared. So I'm squaring the 4x, then I'm multiplying them together, then I'm squaring the 3. So that would be 9. Then I come through with my red, my signs. I do same, so it was a plus, so I put a plus. Opposite, always positive. Okay? All right. So we're going to practice those in class just a couple more times, just to make sure everybody's solid on them. But that's it. And then you'll have some classwork on this factoring on Thursday. Bye-bye.